Question number 22, it says, the gradient of the curve y equals to 4 root x minus 3 over x at point x equals to 1 is, okay, this comes from application of derivative, or you can say application of differentiation. So we use differentiation to calculate velocity, tangents, and normal, also find gradients of a line in a coordinate geometry. So now gradient represented by the letter m simply means what? Dy dx. It means the derivative of that function, or the derivative of the equation representing that curve. So that means for us to find, having given the equation of the curve, that means if we differentiate it, the differentiation will give us, the result of the differentiation will be the gradient or slope. Then when they say at the point x equals to 1, so when we differentiate it, we substitute x equals to 1, and then that will give us the exact gradient at that particular point. So let's first find the y dx. So m, which is the y dx, equals to, this will be 4 into x raised to the power of a half minus 1. Okay, let me do it properly. Okay, sorry. Let me just start a bit from beginning. So if we have y, 4 x raised to the power of a half, square root of x, according to laws of indices, can be written as x raised to the power of a half. Okay, minus 3x raised to the power of minus 1. If you have 1 over x, 1 over x raised to the power 1, if you take it to the numerator, it will be x raised to the power minus 1. If it was 2 here, if you take it to the numerator, it will be raised to the power minus 2. That's still part of law of indices. Okay, so now let's find our dy dx. Our dy dx will be 1 over 2 times 4 x raised to the power 1 over 2 minus 1. Okay, quick recap. Recall, if you have a number ax raised to the power of n, if you have a number, say expression y equals to ax of n, dy dx simply means what? Anx raised to the power of n minus 1. So it is this formula that I'm applying here. Okay, minus, you bring minus 1 times what? Times 3x raised to the power of minus 1 minus 1. So this will be equals to 2 will cancel 4 here, 2. This will be 2x raised to the power of a half minus 1 will give you minus a half. Okay, then minus times minus here will give you plus. So here will be plus 3x raised to the power of minus 2. So therefore, our gradient m, which is dy dx, equals to what? 2x raised to the power of minus a half plus 3x raised to the power of minus 2. So we are not there. So that gradient at a point where x equals to 1, that means wherever we see x in here, we substitute 1. So that our m y dx will now be 2 into 1 raised to the power of what? Minus a half plus 3 into 1 raised to the power of minus 2. 1 raised to the power minus a half will be 1. So that will be 2 times 1 plus 1 raised to the power of minus 2 will still give you 1. That's 3 times 1. So this will be 2 plus 3, which equals to 5. So therefore, the gradient of this curve at point x equals 1 is 5. For broad understanding, you can check out our course proper, Jam Mathematics, where we cover each of these topics in a wide scope. Thank you.